Charlotte and Hakan would like to know what approach or method would you suggest for engaging students to learn, for a love of learning rather than working towards the exams?
Okay, so my understanding of this question is that we're really being asked about how we can get learners really engaged in a way so that they're enjoying the subject. So this is not about some sort of visceral reward response that gets them to look in a particular direction. This is something a little bit deeper. And I think this is a valid challenge that we have. First of all, I'd sort of say that the science of learning doesn't necessarily prescribe any one particular approach. So it doesn't tell us a set of practices that you should use in the classroom. Actually, we already have evidence that tells us the sorts of things that do work in these situations. And in terms of engaging people and nurturing a love for the subject, it's about providing authentic, relevant and meaningful contexts. That's the established practice based on the evidence that appears to work. What the science of learning does is then help you unpack that a little bit more and understand how to implement that. In particular, we've been talking on the course about linking to prior knowledge as being really important to provide meaning. So when we say linking to authentic contexts, these have got to be contexts that are authentic for the learner. And that prior knowledge may involve the experiences that they've had, informally outside, in their leisure time, things they already enjoy. And it's that linkage to that prior knowledge which is both helpful in terms of making the new knowledge meaningful, but also in terms of engaging. And so if you're trying those sorts of practices and it's not working, then the science of learning helps, I think, identify the sorts of questions you should be asking, like, relevant to who, meaningful for who, authentic, in what way, and ask you to sort of question a little bit more deeply why the established practices are or are not working in these contexts. I don't know if that answers the question or not.
I know, I can add just a little bit from my point of view. I think because you can see a change in children's maths learning between when they're in early years settings and when they go up, especially towards upper primary. And in early years, children aren't driven by exam results at all because they hardly even know that exams exist. And I think you can see really clearly in early years maths learning that what makes learning motivating is that children are able to do more and different things once they've learned something than before they learn something. So if children have a more sophisticated understanding of number, they can have more interesting conversations with people they care about and they can solve more interesting problems. And I think that gives you a kind of nice heuristic to use if you're working with learners, is can you be clear about what does this learning help you do that you couldn't do before? And if the only answer you can give them is you can pass an exam now, then that's not going to cut it long term. Children need to have that. I think that's what makes it authentic and relevant and meaningful, is that children can see, this helps me do something I couldn't do before.
I think also there's that thing about choice and autonomy, isn't there? That the more you can arrange situations so that there are aspects of choice and there's some feeling of learning independently rather than just being told, I think the more engaging it becomes.
Yeah. It's hard to motivate yourself just to do something because someone's told you to do it.
Yeah. And actually that's true in a number of different respects. So we know, to talk about the brain's rewards response again, we know that actually you're going to get more reward response in a task where you've been given some element of choice. We have the evidence for that. But then also we've been talking about the reward response provided by shared attention when you're working with somebody. We've been talking about the fact that sharing attention can be rewarding itself, but actually, if you look more closely at that scientific research, it's self-initiated joint attention that produces the greater reward response. So it's being in control enough to be able to draw other people's attention to what you're doing that really provides that engagement. So again, that points to the autonomy of the learner and their independence in terms of being able to explore and discover and point out what they're and show what they're discovering and exploring and learning to others.
Tatiana would like to know, she's asking about learning with disabled pupils, although that's obviously a broad term, but should teachers use the same strategies goes through the course, or are there any additional or other strategies that would help their brain retain information?
So, I mean, my take on this is, I mean, first of all, it goes back to this idea that we all have the same underlying processes. So in that sense, we should be, assuming that people are learning in similar ways, although we're all different and therefore different approaches will be more effective for different learners. So, personalization in that sense and finding out what works for a particular learner is really important. So I'm not saying that I'm not saying that every strategy is going to work the same way with every person. That's not the case. So we do need different strategies for different people, but the underlying processes are the same, and therefore you should be thinking about engagement and the building of knowledge and consolidation of knowledge and the processes that we've talked about. They are generic in that sense, but obviously somebody with a different profile of abilities is going to respond better to some teaching strategies than others.
Mm-hmm. Yeah, so the kind of engage, build, consolidate model is pretty much universal, but you're going to see differences in what is the best way to engage a learner, or how are different learners constructing their learning based on the same kind of stimulus. That's where you'll see the differences, I suppose.
So it's the same principles, but the outcome will be quite different. Yeah. The outcome in terms of what's most effective teaching and the learning that's achieved. So I think there's an interesting sort of, there's an interesting link between both those questions, because they're both saying, what does the science of learning say you should do? And I can't emphasize enough that it doesn't say you should do anything. It really doesn't. I mean, it's what you should do should be derived really from evidence from your own observations, evidence from strategies that have been tried and shown generally to work in particular situations, but then also thinking about those underlying processes so you can understand what's going on. And that understanding is itself, evidence-based. But that's the science of learning bit. And it's not saying you should do this. It's just going to give you an insight into, whether and why something is working or not working.
Yeah. And if you think about something like if a child is struggling, particularly with maths, then the science of learning can give you some clues as to what it might be that's causing that difficulty, because it's generally not the case that it's, there's nothing, maths isn't just one thing, so children's maths learning depends on quite a lot of different foundational skills. So it could be one child might have a difficulty with the language around maths, and that might indicate some kinds of support. And another child, it could be difficulties with working memory or executive function, and that would indicate different support. With some children, it could be poor number processing. So that's what dyscalculia is generally refers to is an inability to process number, and that would lead to you implementing other kinds of support. So I think that the science of learning can help you kind of give you a bit of a map, if you like, as to where you might like to look to try and understand particular learning difficulties.
And what we haven't done very much on this course is to go into the specifics of how we learn to read or how we learn to count and do maths. So this course has really sort of provided the foundations. Mm-hmm. And I think this is kind of like the second part of the course, which is still to be designed, is to then start taking that into specific areas, specific subject areas, really, and understand how learning comes about, the underlying processes of how learning comes about in numeracy and literacy, and why sometimes it doesn't.
Errol would like to know where he can find some more information about what's happening on a physiological and a neurological level during learning.
So there are plenty of good texts available at the moment. I think in the last few years that have come out. I mean, the one that, well, I think one of the first books that came out, which was really helpful for teachers, was The Learning Brain by Sarah Jane Blakemore and Uta Frith. So that was back in 2000. There's also a downloadable free copy of I can't remember what it's called, but it's the science of learning, the learning in the brain, I think it's called, from the OECD. So there are some free materials that you can find online, but I think the thing to always ask with any of these texts that you find is what are the qualifications and the experience of those who are producing the texts. I think it's always good, if possible, to make sure that they have got scientists informed in their production. That's the only thing I would say. And then, of course, I would. The book that I've just brought out, which I've actually written for teachers, is Evolution of the Learning Brain, and this started off as a really as a sort of an introduction for teachers to discover more about how the brain learns in ways that are relevant to the classroom, but set in the hopefully engaging narrative of evolution. So you pass from the emergence of the first cells and how cells appear to learn through chemical signaling, all the way to modern technology and how we learn through technology, but always focusing on the processes as these develop and become more complex. But I think it should be a very accessible read. So I would really, recommend my book, but I do think people will find it valuable.
From Merrill now, a question: Can we get the science of how we learn into the curriculum at key stage 1 to 4 or even 5? If we don't understand how our minds work, how can we expect to understand the complexities of the world around us?
I think it'd be a wonderful idea to see more about the science of learning in the curriculum for our younger students, because actually we know that metacognition is one of the most powerful types of intervention for improving children's learning, and that's all about thinking about your learning processes. And I think one of the problems has been, that sometimes phrases like working memory and things like that feel a bit abstract, and seeing brain activity, I think, helps bring to life some of these rather abstract concepts. So I think there's a real opportunity here for children to think more deeply about their learning and their metacognition by having concepts about how the brain learns introduced into their curriculum. So yeah, I would love to see that. I would love to see that. It's also linked to improved self-concept and this idea of growth mindset as well, knowing that you have a big role in constructing your brain, and that you shouldn't really think about your brain as a sort of limitation on how you can learn, but actually a means to learn more. It's an opportunity.
And I just add a little caution, though, that I think this is happening really well in lots of schools where there's just good practice in classrooms. So children in all of their lessons should be learning how they're learning, if you like. I'm not convinced that adding it into the curriculum would be the way to do it, because in a way that partitions this off from everything else. But, because in good schools, I think children are learning about how they're learning in maths, in science, in English, in geography, history, and so on. And good teachers will be helping, reinforce the growth mindset, reinforce good metacognitive practices through what they're doing in other ways.
I suppose I'm aware that a lot of teachers are asking me, because I've been doing a lot of presentations on this to teachers lately, and I always get teachers coming up and saying, are there resources available so I can introduce these ideas to my children? And I'm not really sure where to point them to. So I guess there is work to be done.
But I think this is what I mean. I don't think, I suppose it does depend on what children we're working with. But I think especially with young children, this isn't something to make children's responsibility. It's the teacher's job to know this kind of stuff and structure teaching and learning so that children are learning how to learn. It's not children's responsibility to know these strategies and what counts as good practice in the classroom, I don't think. It's all the kind of language teachers are using is having an effect on how children think of learning. So, like in a primary classroom, it makes a big difference if a teacher is saying things like, oh, okay, we're going to have a really good struggle with this now, because that kind of gives children the idea that difficulty in material isn't something to run away from. It's something to be happy about because that's where we're going to learn. So that's what I mean by it being the teacher's responsibility to be making sure that a good sense of what learning is communicated to children, rather than making it children's responsibility to learn this and how they should be learning. I think it comes through in all of the kind of teaching that a teacher does in the classroom.
But surely if we're trying to produce autonomous learners, we have to be encouraging learners to take some responsibility for their learning. Yeah.
I think there's a difference, though, isn't there, between taking responsibility for your learning and understanding all of the science behind that. I think you could see a lot of children in primary school classrooms having autonomy for their learning and taking it in their own directions without having science of learning as part of the curriculum.
Sounds like a good area for research, whether it actually helps or not.
It probably needs a longer discussion, doesn't it, than what we've got here. Yeah. And I definitely think as children get older, if they're thinking about, there's a lot more of learners' own structuring of their learning towards, especially exams at GCSE and A-level. And I think it probably would be useful for them to have a bit more of that structure of understanding of how they're learning.
Do you think that there's a particular age when brain plasticity could be introduced to students?
And for me, that's similar to the last point. I think teachers and parents and all the adults around a child are quite well often giving children messages about what their capabilities are and what's possible for them. So I think from the very earliest age, children are getting these ideas of what are they capable of and how ambitious can they be. So I think when children are very young, they are getting this message, but maybe it's a bit more subtle. Some children will think, they can do anything, they can achieve anything, and other children will think, I'm never going to be a maths person. Because maybe their mother or their father said, I was never a maths person. Do you see what I mean? So children are learning about brain plasticity all the time in different ways. And I think the important message is for parents and teachers to be aware of that and to be aware of the kind of language they're using that's going to affect how children think of themselves.
Yeah, so there are many ways in which you can get the message over to children that they they shouldn't feel themselves, limited by some biological factor. but then, and I guess brain plasticity is one of those ways, but there are many others as well. I mean, there is evidence to suggest, there's 2 studies that have shown interventions involving brain plasticity having a positive effect on children's self-concept. So I think it's something that we should be thinking about introducing. I'm not sure. I don't think it would be necessarily particularly appropriate for like young children in primary school. I wouldn't have thought, because you need to know actually something about the brain in order to understand what brain plasticity is. But it is I think it might be a useful concept to introduce when we tend to have those sort of dips in self-belief and self-concept approaching adolescence. That might be when I think probably children could benefit a lot from knowing more about how their minds and their brains work, both in terms of mental health and their academic achievement. And I'm sure brain plasticity is one of the concepts that should be included in that. I would see it as a secondary school sort of area.
Karen asks, what would be your advice when it comes to avoiding an avoidance response if you're teaching something that might be difficult or considered boring?
I guess as an ex-maths teacher, I'm really familiar with that. And so I certainly met lots of children that thought of maths as difficult and boring. I think this really links back to an earlier question about how can we try and make sure that children aren't seeing any subject or any learning as just something they're doing to pass exams, because that really opens you up to all these difficulties that they can see as just difficult or boring. I think it's trying to find that other purpose and helping children explore ways in which that content can be meaningful for them. And for me, it comes back to that idea of what can we do now that we know understand this new concept, or now that we've got this new knowledge, what can we do now that we couldn't do before? On the difficulty thing, I think that links back to the brain plasticity and the helping children learn how to learn, and that's it needs to be a kind of whole school culture that difficulty is not something to run away from. When something is difficult, and we kind of meet that difficult or challenging material, that's when we're really going to be learning. If we're doing easy stuff all the time, we're not really going to be learning as well as we might. And it really comes back to that science of learning model. That bit of construction is when we're connecting concepts up in new and different ways to allow us to think in more sophisticated or more interesting ways than we did before. And that happens when we're faced with difficult situations that we can't deal with in the ways that we have done sort of when we were younger or when we didn't know this new material. So I think that getting used to appreciating difficulty is something to tackle at a whole classroom or whole school level, I think.
Yeah, I think it's important as well for the teacher to feel confident in the concepts. Mm-hmm. So, going back to what we were talking about with the mirror neuron system on the course and the ease with which emotions can be unconsciously communicated, I think it's important for teachers to have rehearsed their understanding sufficiently to feel confident in what they're doing. But also if they can find ways of talking about it that they feel generally enthusiastic and interested in, as well as, hopefully finding contexts and ways of talking about things that are authentic and relevant and meaningful for the students.
Mm-hmm. Yeah, it's difficult for a teacher to help children think that difficulty is a good thing and challenge and struggle are a good thing if they're not demonstrating that in their own actions, is it?
Mm.
We've had a couple of questions linked to rehearsal and practice. One is how much time you need to spend practicing something in order to really remember it. And also, how soon after learning should you practice and consolidate? Is there some kind of are there any set time frames for these things?
Well, I mean, the research shows that there are set time frames, but unfortunately, it's very difficult to predict them because it varies with the content, and it varies with the time from the final test. So when you should actually rehearse material, depends on when you most want to be able to access it in the future. So rehearsing it just immediately after you've learnt it and not touching it again is not going to help if you've got the exam in 5 or 6 weeks time. So it's a matter of, I mean, to my mind, rehearsing it so that you feel comfortable with it, and you're not sufficiently for you not to have to be thinking too hard about it when you're moving on to new material, and that comes down to the working memory capacity again. But also, of course, these things need to be regularly returned to and revised, so that it shouldn't just be left behind. I think that's the other important thing. It should be rehearsed, occasionally in the period that follows up until the final exam, or whenever it is that the information needs to be recalled and understood. I don't know if you've got any ideas on this, Tim. It's a tricky one, I think.
I did just want to come back to that. One of the questions was how much time you should spend on rehearsal and practice. And I wanted to say there's just so much variation between people and between different kinds of material that you might want to be rehearsing and practicing. So some children will remember, some children just have good memories, and some children take longer to learn the same material and will need more practice. And you can see that there's a big focus on arithmetic fluency in primary schools at the moment, and with the new times tables screening test, learning times tables. And times tables is just something that children need to learn to some extent. It's kind of a rote learning exercise, and some children just need much more practice than others. So it's very difficult to say. The only data you could get would be an average across groups, and that would hide quite a lot of this variation. So it's not really possible to say for any person without understanding them as a learner how much practice they're going to need. I would say what we know is it's not just about practice. There's good and there's better and worse quality practice. So doing some thinking with the material, or putting it into new contexts like we talked about in the course, or doing some other work with the material to be learned will help.
And also spacing out the sessions that you're rehearsing over time. So spaced learning can help as well. Yeah,
so 3 blocks of 20 minutes would spread out would be more effective than doing it all in an hour, because that second half an hour in an hour block won't be as effective. It's a bit like sports. Interval practice is a bit better for training than trying to do it all at once, because your brain just gets tired out if you spend too much time on one task.
We're going to think now about cognitive load. Does cognitive load reduce if students are told what skill to use at a specific point in time during teaching?
I think that could even potentially make things worse. I think if there's, I think the question is talking about having words to listen to as well as text to read on a board, and whether giving students guidance on which of those two things they should be attending to could help. I think I would say if there's information in front of people, they'll be attending to it. So if there are spoken words, you can't help but listen to what those are. And if there's written words in front of you, you can't really help but pay attention to those. So if you really want pupils to focus on what the teacher is saying, then it's best to make sure that there aren't any other words about to listen to that are saying different things to what the teacher is saying.
I actually tried this Sorry.
Oh, go on. No, go on, Paul.
So I actually tried this with some students yesterday. I put a sentence on the board and I said, I really want you to look at this sentence and not to read it. And nobody in the room was able to do that because we are automatic readers. That's how it operates. And I think...
It's like telling people, don't think of pink elephants, isn't it?
Yes, yes, it is. So I think one of the things we need to avoid, I mean, you can have like... Because I think also on this question, we were being asked, is there like a certain amount of text or whatever that should be, avoided? And I think that, or should you just, remove all text from a slide or whatever? But actually, certain labels are really helpful. So small amounts of text can be quite helpful. I think that even if somebody is talking, it is possible to glimpse those labels, and that can really help. What we want to avoid is having chunks of prose that require you to maintain attention to actually read that sentence, because you're going to be doing it if it's on the board. And that makes it very difficult to attend simultaneously to what the teacher is saying.
Can we consider working memory as a muscle that can be trained to overcome working memory limits?
Oh, wow. There's a lot of argument and discussion about that. I mean, it'd be interesting to hear what Tim's take is on this. It does. I mean, can you train working memory? This is what the scientists are arguing about. And it seems to be possible within particular contexts, but it's difficult then to transfer it from one context to the next. So I think children will develop working memory, in terms of particular mathematical problems if they're practicing lots of those particular mathematical problems, and that can be quite helpful. But probably what isn't helpful is thinking that you can generically train up working memory. That's much more difficult. There are some studies that show it might be possible, but I'm not sure it should be a target for a teacher. I think it's better to accept the fact that you're working within specific contexts and you're developing cognitive functions quite often, that are actually in relation to those contexts. What do you think, Tim?
No, I agree. There's very few studies that have shown you can increase working memory capacity, like generally. But I think what you can do, and we've talked about this a bit on the course, I think, is you can get better at using the working memory resources that you have. So as you come to have better knowledge or better understanding around a particular topic, then you're able to work with bigger chunks of information, say. So one thing that happens as you get better at working with numbers is with your 7 plus or minus 2 bits of information you can keep in working memory, instead of using those 7 slots for 7 single-digit numbers, you could work with 2 or 3-digit numbers. So you're kind of working with more information, but you do that by chunking because you've got that knowledge that allows you to work with bigger lumps of information, if you like. So I think we can help children use their working memory more efficiently, or partly just by giving them lots of practice solving different kinds of problems and working with different kinds of information. But you can't actually change the working memory limits kind of universally. Yeah.
And I think another important part of using your working memory efficiently is employing strategies which allow you to offload your working memory, including showing your working, and putting it on the paper. And so many times I know children think that that's just so that they can prove to their teacher that they're doing it in the right way. But actually showing your working is performing that really important task of offloading working memory so that you don't have to remember a lot of the things that you've already done, but they're there should you need to refer to them, while you can get on and employ all your attention to the next stage in the process. And then, of course, there's also, so that's the learner scaffolding their own working memory, but then there's also the teacher sort of, thinking about offloading some of the working memory burden by providing information in an accessible form and avoiding distractions and all the rest of it. it is about using what you've got. I really agree with Tim about that.
And this question came up during the course as well, in reference to the sequencing letters or grouping letters, wondering whether it works the same with adults and children, or is it better in adults because of what you've just explained about chunking?
I think that would be the same for children as it would be for adults. It's just the chunks just need to make sense. So the ability to chunk, you can do that because the chunks are familiar. So remembering letters when they're grouped, and those letter groups represent familiar acronyms or abbreviations. We can only do that if those abbreviations or acronyms are genuinely familiar, and we know those. So children can do it as long as the chunks are meaningful for them, and they've had lots of experience of hearing and seeing and speaking them, that kind of thing.
I mean, a good question is also whether it's better for the child to make up the acronym, in a way that they remember it. So sometimes you can, or is it better for the teacher to provide the mnemonic strategy? And I think quite often it's better if the child can actually create a way of remembering something themselves, because it's going to be more meaningful and memorable for them.
In terms of engagement, how does internal motivation link with what we've learnt this week?
Well, this is an interesting question. So concepts about intrinsic and extrinsic motivation are often referred to by psychologists to mean sources of motivation from within, such as fascination with certain things that you find fascinating, or being offered some extrinsic reward like money. But actually the way that these things appear to activate the brain are very similar. So it's not clear to me how useful the extrinsic intrinsic differentiation is. I mean, there's a lot of things that are extrinsic that I feel intrinsically motivated towards. So, if somebody comes along and offers me £1,000 for something, I'm quite fascinated with that proposal. so I'm not sure about this. About how useful it is to think about it. Certainly at the brain level, the two things appear to be very similar, and it's you don't tend to find internal, or extrinsic or intrinsic words being used in brain imaging papers because of that. What do you think, Tim?
I think that, well, like you've just said, really, they're more closely linked than the words make them seem. So it seems like it's quite black and white, that motivation is either intrinsic or extrinsic, or internal or external. But they're quite linked, because that example you gave of the £1,000, it's not the money in itself that might be motivating, it's the anticipation of what you might be able to do with it, which could be partly intrinsic, and it's partly intrinsic and partly extrinsic, isn't it? I think the only thing I would add is that if you're thinking about how extrinsic rewards work in classrooms, the things like stickers, reward charts and so on, is that you need to be a little bit careful about how that works, and how that could potentially limit other kinds of motivation. And from long history of learning experiments in psychology, we've got the Premack principle, which is that for a reward to be effective in making a behaviour happen, so for a reward to be effective in reinforcing a behaviour, it has to be more desirable than the behaviour itself. So in a sense, it can be a little bit limiting. If children learn they're just doing some kind of job, or they're just doing some kind of activity for the reward, then that can have the effect of limiting the kind of intrinsic reward from that activity, because the reward, the extrinsic reward, is only effective if it's more rewarding than the activity itself. So you could, if you start with stickers, I guess you want to have a transition in mind, because you don't want to be always having to reward activities in the classroom with stickers. You do want children at some point to find learning rewarding in itself. I guess we've got different kinds of activities in the classroom, haven't we? Sometimes we are doing the kind of rote learning, repetitive practice where rewards can help. But if you can help children see then that all that learning they've done is allowing them to solve more interesting problems and do more fun activity, then that gives you a transition into more intrinsic rewards later on.
I think the other thing is that when you think about why children find stickers rewarding, I mean, at the beginning they're a novelty, but actually, later the rewarding nature of a reward, especially something like a sticker, it's essentially sort of cultural, and it's very it doesn't stay. It's not constant. It's a constantly changing thing. And what seems to happen in the brain is that the reward system becomes, the connections form between the reward system and representations in the cortex of these different things, and those connections change according to experience. And so the actual rewarding value of a sticker will change over time according to the way in which you experience that sticker. And if it's given out in a sort of perfunctory way, over time it will very quickly lose its motivational value. If, on the other hand, it's a more deeply part of the culture where stickers can accumulate and then they're sort of swapped between friends, or they become, you get enough stickers to be able to do something with them, then actually the value of the sticker as a motivational factor can increase. So there's I think it's just worth remembering that it's the culture around the stickers that actually makes them valuable. And that's what gives that intrinsic sense that I want a sticker. And
then in that example that you're giving of how that can change over time, that could be quite different for different children in a room, because if some children tend to be the ones that get lots of stickers, it might be more motivating for them because they get that approval from the teacher and they're getting to collect more, and they've got that kind of competition within the class. Whereas if you're a child that tends not to or hasn't in the past, then that might be demotivating, and they might, you could get your child thinking, oh well, keep your stickers. I think it's just something to be. I think it's something to think about. If those kinds of external rewards are being used in the classroom, there is that complexity of, like you say, over time and different experiences in the classroom.
Yeah, I'm just laughing because I remember experiences of my own where children have actually said, look, I will do this if you don't give me a sticker. Because the way in which stickers were given out had just become so uncool. So they can get a negative status actually in some contexts.
So thank you to Paul and Tim. There's been some really interesting answers there. Is there anything you want to share about where this research is going next?
Well, I don't know. On a scientific level, we need many more studies that are using techniques like brain imaging, but other techniques as well, which are really focused on educational contexts. So I think one of the things that we've had to do on this course is make some pretty big leaps sometimes. Those are leaps that have been done very carefully and thoughtfully. And we're trying to publish, work on the assumptions behind those. But it's also revealed some, gaps in the science. So there's quite a lot of scientific research to be got on with. But there's also work, I think, in the classroom, and there's a lot of questions that I want to know more about. And one of them is what concepts teachers find useful and helpful, and how teachers think about learning and the way in which the science of learning interacts with those ideas. So that's the research that I think that needs to take place. And I'm very grateful, I should say, to the many participants on this course that I've contacted and asked whether I could use their thoughts as part of that research to help understand more about how teachers are thinking about learning and how the science actually impacts on that thinking.
Yeah, I think the work that I've been doing recently is more in that sort of latter set of bits of work you're talking about, Paul. So I've been doing quite a lot of work with early years teachers, talking about the science of children learning about number and kind of early foundational mathematical concepts, and then working with those teachers to see how they're interpreting the science of learning and what that's making them think about what's going on in their classrooms, and designing interventions in their own practice to see if that makes a difference. So all that work's ongoing, but I think, and that's very much building on the kinds of things that we've been trying to do in this course, isn't it? Is thinking, how do we translate this into practice, and what kinds of translations are really useful for children's learning?